Mystery, how are we doing today? Hopefully y'all are doing well. So today we are going to be doing our notes on empirical and molecular formulas. Now this is the last thing that we are going to cover before we leave for our winter break. So just kind of power through it and we'll get there, all right? So again, empirical and molecular. For this, please make sure you've got your notes, something to write with. You will need a calculator and then you'll also need a periodic table. All right, so make sure you've got all that stuff, but otherwise let's go ahead and get started on this. All right, so first off, what is an empirical formula? So an empirical formula is basically us looking at a compound and giving the simplest whole number ratio that we can for that compound. All right, so what does that mean? Well, I like to give glucose as an example. So glucose, if you remember, is C6H12O6, right? So you've got carbon, there's 6 of those, hydrogen, there's 12 of those, oxygen, there's 6 of those. So that right there is what we call the molecular formula for glucose, okay? So what is the empirical formula? Well, again, it's the simplest whole number ratio of this. So the whole number ratio for this would be carbon, I've got 1 of them, hydrogen, I've got 2 of them, oxygen, I've got 1 of them. So the empirical formula for glucose is CH2O. The molecular formula for glucose is C6H12O6, right? Okay, and so what we see here is it's essentially just the reduced version of it. It's us looking at and seeing, okay, well, what is the ratio of these elements that we have? Okay, so let's actually look at how we would solve for empirical formulas. Okay, so empirical formulas, what we're going to do is we're actually going to start with the number of grams of each element given in the problem. If we're given a percentage, we're just going to make the assumption that it's out of 100 grams, okay? And we know that if we've got the assumption of it's out of 100 grams, then your percentage equals how much mass you have, okay? The next step we're going to do is we're going to convert that mass into moles, right? When in doubt, moles it out. So we're going to convert that into moles using our molar mass that we find from the periodic table. The next step that we do is we're going to divide those moles by the smallest molar number that we get. Okay, so if I got a 1 for the first one, a 2 for the second one, and a 2 for the third one, I would divide them all by 1. Okay. The fourth step is we are going to find our nearest whole number ratio. Okay. If the number is too far to round, then what we're going to do is we're going to multiply it by a number until we get to that whole number ratio. Okay, so what I mean by too far to round, if you end up dividing by the smallest and your answer is like 2.25, then you're actually going to have to multiply that by 4, right, to get it up to a whole number. But what you do to one, you have to do to all of them. So if I multiply one of them by 4, I have to multiply all of them by 4. All right, so keep that in mind. If it's 0.33 or 0.66, you're going to have to multiply by 3. And then if it's 0.5, you're going to have to multiply it by 2. So it typically is going to end up in one of those 4 ratios if it's not super close to the whole number at like 2.999, right? If it's 2.999, then we would just round that up to 3. Okay, so let's actually look at how we would use this. Now, I know those rules probably didn't make a whole lot of sense, right? Well, for me, the way that I've always remembered how to do empirical is I've kind of said this little ditty in my head. And that ditty is percent to grams, grams to moles, divide by the smallest and multiply till whole. Okay? And if you say that over and over and over in your head, it's going to make this super easy for you when you are solving for these empirical formulas. All right? So again, that little ditty is percent to grams, grams to moles, divide by the smallest and multiply till whole. Okay, so make sure you got that kind of stuck in your head, but let's go ahead and actually use that. So my first question here says, find the empirical formula of a compound found to contain 53.70 grams of iron and 46.30 grams of sulfur. Okay, so thinking about our steps for solving for the empirical formula. The first step is percent to grams. Okay, so looking at my problem here, it says I have 53.70 grams and 46.30 grams. Okay, so thinking about that, have we already done percent to grams? Well, yeah, we have, right? We're in grams already. So first step is already out of the way, so we can move on to the next step. So percent to grams is done. The next step is grams to moles. So grams to moles, how do we convert from grams to moles? We're going to use our molar mass. So I have 53.7, let me fix that 5 there for you, 53.70 grams of iron. And we're going to convert that into moles. So grams of iron into moles of iron. We're going to do that using our molar mass. So 1 mole of iron is 55.85 grams. All right, plug that into our calculator. We're going to get 0.9615 moles. Okay. Next, we're going to do the same thing with our sulfur. So we've got 46.30 grams of sulfur. So 46.30 grams of sulfur. Again, that came from my problem. I'm going to drop down grams of sulfur and go into moles of sulfur. I know I have 1 mole for every 32.06 grams. Plug that in. I'm going to get 1.444. Okay, so I've done percent to grams. That was already completed for me. Grams to moles. The next step is divide by the smallest. So looking at my two answers here, I've got the 0.9615 and 1.4444 or 1.444. Which of those two is smaller? Well, the 0.9615 is, right? So we're going to divide both of those by 0.9615. Okay? So take that. We're going to plug that into our calculator. We divide a number by itself. We get 1. Here I divided 1.44 by 0.9615, and I found out in my calculator I got 1.5. Okay, thereabout. It's kind of rounded. Okay, so now I look at this number and I multiply till whole. So I've done percent to grams, I've done grams to moles, I've divided by the smallest. The last step is to multiply till whole. Okay, so looking at this, is 1 a whole number? Yes, it is. Is 1.5 a whole number? No, it's not. So what am I going to have to multiply this 1.5 by to get it into a whole number? 2. So I'm going to multiply 1.5 by 2. Now, what I do to one, I have to do to the other. So I need to come back up here and also multiply that 1 by 2 as well. So I'm going to get 2 and 3. So for my iron, I found I had 2. And for my sulfur, I found I had 3. So then when I write my empirical formula, I would put Fe 2S 3. That would be my empirical formula. So this would end up being my answer. Okay? So let's do this next one. So it says, find the empirical formula for a compound found to contain 32.38% sodium, 22.65% sulfur, and 44.99% oxygen. Okay, so thinking about our empirical formula, we know percent to grams, grams to moles, divide by the smallest, multiply till whole. So we've got those 4 steps that we need to complete. So the first step is percent to grams. Okay, so we haven't done that yet, right? But remember that what I told you is we're going to assume our percentage is out of 100 grams. So if I have 32.38% sodium, so 32.38% sodium is going to be 32.38 grams of sodium. Okay? I'm going to do that same thing with all of them. So I have 22.65% for my sulfur, and that's going to turn into 22.65 grams of sulfur. And then I have 44.99% oxygen, and that's going to turn into 44.99 grams of oxygen. Okay, first step is done. Next step, so I did percent to grams. Next step is grams to moles. So we're going to take this, we're going to convert these grams into moles. We're going to do that using our molar mass. So grams of sodium into moles of sodium. 1 mole is equal to 22.99 grams. Plug that into my calculator. I find I have 1.408. Keep on going. Convert this grams of sulfur into moles of sulfur. 1 mole, 32.06 grams. Solve for that, we're going to get 0.7065. And then we do the same thing with our oxygen. So grams of oxygen into moles of oxygen. 1 mole is 16.00 grams. We solve for that, we're going to get 2.812. All right, so we did percent to grams. We did grams to moles. The next step, divide by the smallest. So looking at my three answers there, what's my smallest? This 0.7065. So we're going to divide all of those by those numbers, or by that number, 0.65, and divide it by 0.7065. I'm going to plug those into our calculator, and we will find that we have 2, 1, and 4. Those were all very, very close to each of those whole numbers, so we just rounded it up. Now, this would be 2 for sodium, 1 for sulfur, and 4 for oxygen. So now I can actually rewrite. Well, so first off, before we do that, what's the last step? The last step is multiply to a whole, right? Well, all three of these are whole numbers, so we can skip that step. So I have Na, there were 2 of those. Sulfur, there's 1. Remember, we don't write a 1. And O, there's 4. So then this is my empirical formula. Okay? All right, so I want y'all to go ahead and practice on this next one. So pause your video, work through it, then unpause your video, and I will go over it with you. All right? All right, so let's take a look at this one. So I first off started with percentages. I had 63.15% carbon, 5.30% hydrogen, and 31.55% oxygen. I took that, converted it into grams. Remember, just a direct conversion since we assume it's out of 100. Now, we're then going to go from grams into moles. I did that using my molar mass, and my answers were 5.258, 5.248, and 1.972. Then I divided by the smallest. So my smallest number was 1.972. I got 2.66, 2.66, and 1. But those are not whole numbers. And so since they're not whole numbers, I need to multiply them until they are whole numbers. So I'm going to multiply by 3. So I get 2.66 times 3, which is 8. Same thing, 2.66 times 3, which is 8. And then 1 times 3, which is 3. That gave me 8 carbon, 8 hydrogen, and 3 oxygen. So then I would come back over here, plug that in, and I would find my empirical formula is C8H8O3. All right, so that is empirical formula. I'm going to leave this next one for y'all to do as practice, but otherwise I'm going to go ahead and move on. So for molecular formulas. So a molecular formula is basically, like I said earlier, just the non-reduced version for the empirical formula, right? So it's going to be talking about the specific element. It's going to tell us exactly how many of each thing we have. So what it's going to do is it's again going to show us how many atoms of each element are present in the molecule of the compound. It's going to have the same ratio as my empirical, but there's going to be a different number of atoms. Why? Because now we're telling us the exact picture, the exact thing that we have. Okay? So how do I figure this out? Well, first off, I need to find the multiplier. So with your molecular formula, you know that it's all of those numbers that are multiplied by something, right? You take your empirical formula and you're going to multiply it by some factor, some multiplier. Now, how do I figure out what my multiplier is? Well, what I'm going to do is I'm going to take my molar mass of what we call the molecular formula, so the molar mass of the entire thing, and then I'm going to take the molar mass of my empirical formula and divide the two. When I do that, that's going to give me a single whole number, okay? And I'm going to use that to multiply by my empirical formula. Now, that probably doesn't make sense just talking about it, so let's actually solve for what that looks like. So here it says, determine the molecular formula for the following. Before you can solve for molecular formula, you need to know the empirical formula. Why? Because you need to know those ratios. So here I'm already given my empirical formula. So I have B2H5. So I'm going to have to solve for the molar mass. So I have boron. Remember, to solve for molar mass, I'm going to take that number, I'm going to multiply it by its molar I'm going to take that and multiply it by how many boron I have. So the molar mass of boron is 10.81 times the 2 boron I have, which is going to give me 21.62. Then I'm going to do the same thing with hydrogen. Hydrogen has a molar mass of 1.01 times the 5, which is going to give me 5.05. Add those together, we're going to get 26.67 grams per mole. And that would be the molar mass of my empirical formula, right? But they're not asking for the molar mass of my empirical formula. They're asking for the molecular formula itself, okay? So how do I figure this out? Well, I know that the total molar mass is 54 grams per mole. So I'm going to take that and I'm going to divide it by the empirical formula molar mass, 26.67 grams per mole. So why would I do that? What that's going to do is that's going to tell me how many of that empirical formula are actually in the actual molecular formula. So I'm going to take that, I'm going to plug that into my calculator, and I'm going to get something like 1.99999, something like that, which is basically 2. Well, that is your multiplier. So I'm going to take this 2, and I'm actually going to multiply that by my B2H5. So what does that give me? What that gives me is I have B4H10. And this would be my molecular formula. So I have 2 of those, or 2 borons, but I multiplied it by 2 because that is my multiplier, right? And then I'm going to get 4 from that. Same thing with hydrogen. I'm going to multiply that 5 by that 2. I'm going to get 10 hydrogen. So my formula was B4H10. Okay? So I actually want y'all to give this one a try. Solve for the molecular formula for C2HCl. Okay? So pause your video, solve it, and then we'll go over it. All right, so let's take a look at this one. So what you should have ended up with is C6H3Cl3. How did we get that? Well, first off, we found our molar mass for our empirical formula, which was 60.48. Then we're going to take our molecular formula mass, 179, and divide it by that empirical formula mass, 60.48. So 179 divided by 60.48, and that gave you 2.96. Well, that rounds to 3, right? So it's very, very close. You should have a number that is very, very close to a whole number. So you're going to round that to that whole number, which would be 3. Then we take that and multiply it by our empirical formula, and then that would be how we get the molecular. Okay? And so that would be how I got to C6H3Cl3. Okay. I'm going to leave this next one for y'all to do, and I'm going to slide on down here to this one right here. So it says a compound with a formula mass of 180 grams per mole. So it's the entire mass. It's the mass of everything. It's found to be 31 grams carbon, 5.20 grams hydrogen, and 42.0 grams oxygen. So you're like, okay, well, how do I use that? Well, so what we need to do is we first need to solve for our empirical formula. So we're going to go percent to grams, grams to moles, divide by the smallest, and multiply to a whole. And then we're going to go back and do our molecular formula solving using that molar mass. Okay? So first off, let's go convert this into the empirical formula. So first off, have I done percent to grams? Yes, right? I'm already in grams, so I don't need to do that step. Next step is grams to moles. So I have 31.0 grams of carbon. We're going to convert that into moles of carbon using our molar mass. So 1 mole is 12.01. We plug that into our calculator. We get 2.58. We're going to do the same thing with our hydrogen. So we were given 5.20 grams of hydrogen. We're going to go from grams of hydrogen into moles of hydrogen. Again, using our molar mass, 1.01. Plug that in, we get 5.15. And then we do 42.0 grams of oxygen. Convert that into moles of oxygen. 1 mole is 16.00 grams. Solve for that, I get 2.63. Next step, divide by the smallest. Our smallest number for my answers is 2.58. So we divide them all by 2.58. And what we're going to get is 1 and 2 and 1. So we had 1 carbon, 2 hydrogen, 1 oxygen. So from that, I found that my empirical formula is CH2O. Okay, now I've got my empirical formula. So now I can solve for the molecular. So carbon has a mass of 12.01 times 1 gives me 12.01. Hydrogen has a mass of 1.01 times 2 gives me 2.02. And then oxygen has a mass of 16 times 1 gives us 16. We add all of those together, we're going to get 30.03 grams per mole. Well, they told us that the molecular formula mass is 180 grams per mole. So I'm going to take 180 grams per mole. I'm going to divide that by the mass of my empirical formula, which was 30.03 grams per mole. And what I'm going to find is I get a multiplier of 6. Now I take that multiplier, 6 times my empirical formula, CH2O. That's going to give me C6H12O6. So that would be my molecular formula. So we solve for glucose, right? So that is how we do molecular formulas. So I want y'all to go ahead and solve this next problem. So a sample of TNT, a common explosive. I want y'all to work through that, pause your video, work through that, and then we will go over it as soon as it is time. All right? Okay. All right, so what you should have first done is convert from grams into moles. Again, we do that using our molar mass. You should have ended up with 0.0735, 0.218, and 0.147. Once you've done that, then you divide by the smallest, which was 0.0735. You should have ended up with 1, 3, and 2. So you had 1 nitrogen, 3 hydrogen, and 2 carbon. That would be our empirical formula, NH3C2. Then we solve for the molar mass of the empirical formula, which we found to be 41.06. Take that number, divide it by the molecular mass, the molar mass, which was 123. So 123 by 41.06 gave us 3. Then we take that, multiply it by the empirical, so 3 times NH3C2, which gave us N3H9C6. And then that would be our final answer. All right, y'all, so that is it for our notes on empirical and molecular. As always, let us know if y'all have any questions, but otherwise, y'all have a great rest of the day. Bye, y'all.